Well, here we are one more time. Figured I would give you guys a little engine performance stuff. Most of the stuff that people seem most interested in is engine performance or electrical related, and I just figured I'd go ahead and throw you another engine performance primer. Some people, this actually will help you a little bit, I think, if you're trying to prepare for your ASE. Maybe not. I don't know. One way or another, we have a good time here. We'll start out with a verse from Proverbs. If you see a man skilled in his work, he'll stand before kings. So the people that know the best what they're doing are the ones that the folks with money hire to get their work done. That's what you need to remember about that. Another one is the measure of knowledge that you share will be the measure you receive. Basically, you get smarter the more you share knowledge. So share knowledge every time you get a chance, because it just always makes you a little bit smarter when you explain something. I used to tell my students, if you want to burn in these particular principles that I'm putting forth, find somebody that's got the patience to listen to you explain them and ask intelligent questions, and you'll do better about remembering them yourself. So let's move on. There's a machine that breathes, has moving parts, converts power into motion for the purpose of doing work. Internal combustion engine. A lot of your hybrid vehicles even have an internal combustion engine, operates by some slightly different rules. That's another lesson for another time. But basically what you got here is you have an engine that takes air and fuel, turns it into power. Alright, and so combining air and fuel generates force. Our atmosphere is 78% nitrogen, 21% oxygen, and 1% other stuff. Now, if you took 100,000 molecules of atmosphere, and what you would get if you measured the amount of carbon dioxide in 100,000 molecules of atmosphere, there's 35 molecules of a random sampling of 100,000 that are carbon dioxide. And carbon dioxide is supposed to be the big bad wolf, whenever it comes to so-called climate change. Of the 35 molecules of carbon dioxide that are present in a random sampling of 100,000 molecules of atmosphere, one of those 35 is man-made. And when the exhaust goes out of the cars, it settles into because the atomic weight of carbon dioxide is 44, and the atomic weight of oxygen and nitrogen are like 14 and 16. So carbon dioxide is a heavier gas, and that causes it to settle into the ground, and it feeds the grass and that kind of thing. And so that's another lesson for another time. The treated exhaust, comes through here. You got hydrocarbon fuel, which is basically you got your hydrocarbons are basically what can unite with the oxygen when a spark happens. But you got to remember, most of this is nitrogen, and when that combustion process takes place, what you got going on there is that whenever that burn takes place, that it causes the nitrogen to expand, and it's expanding nitrogen that actually pushes the piston down. So I think one of my fellow instructors calls that nitrogen working fluid. Okay. All right. So on a non-turbocharged engine, here's a good question. Why does the air enter the cylinders? What force causes the air to enter the cylinders? It's not a difficult question. Most of you have already probably answered it while I was talking. But the pressure differential, you got 14.5 pounds per square inch at sea level, more or less, or about 14.7 or whatever. And whenever you're drinking out of a cup with a straw, you're going to start with a small cavity in your mouth, and because of the flexibility of your jaw, you can make that cavity bigger, and that causes lower pressure, and atmospheric pressure pushes on the liquid, and it causes it to go up that straw in your mouth. Well, whenever you take a small place in the combustion chamber, because the piston's all the way at the top, and you begin to move it down, the pressure drops in there, and all of the naturally aspirated engines, meaning non-turbocharged or supercharged, the air is going to go in there because the atmosphere is pushing it in there. All right. Now, remember these strokes in order: intake, compression, power, exhaust. Okay? Intake, compression, power, and exhaust. Intake, compression, power, and exhaust. All right? remember those. 14.5 psi at sea level, that's a rounding figure. You got an air filter here, and the air is going through. There's a throttle plate that regulates it. That also enables you to have engine vacuum, because when the pistons are working and the throttle is closed, the engine can't run very fast, but it also creates really low pressure in the intake manifold in the plenum chamber. Alright, so here is a little waveform of that. That's your whenever you've got your power stroke. In other words, the beginning, the compression is at its peak and the combustion happens here, and then as the piston goes down, you're going to see the pressure in that cylinder. It's the pressure waveform. Pressure in that cylinder is going to go down. Right here's where your exhaust valve is open and the piston's going back up. Well, it obviously doesn't make as much pressure because the exhaust is letting that pressure out. The exhaust valve is. And then right here, you got a little overlap between you when both your valves are open at the same time, and the pressure is coming in, and then as it squeezes it again, it's the same cylinder over and over again. That's just a little quickie on that. Okay, so you got a mass airflow sensor that's going to measure the incoming air, and there's various different ways mass airflow sensors work. There's hot film sensors, there's hot wire sensors, there's sensors that use sound waves. There's all kinds of mass airflow sensors. Then you get your throttle plate as it opens. Your mass airflow sensor. If you're ever looking at a trace on a scope, your throttle position and your mass airflow will go together. If you've got them tracking together, they're going to go at the same thing. If you match the throttle and the mass airflow doesn't change, there's something rotten in Denmark. Also, if you get a crack in that tube and the engine torques and opens that crack, you'll have this because as it opens up, it under-reports the air and it loses power and so on. But that's another thing too. There's your map sensor. A lot of vehicles now has got map sensors and mass airflow sensors on them. And they use the map sensor to back the mass airflow sensor up, or they use it to determine if EGR is flowing, because when EGR is flowing, intake vacuum drops, and it can actually use the map sensor for feedback on some engines. Throttle position sensor is going to tell the computer where the throttle is. Your cam sensor is giving it, it uses the cam sensor and the crank sensor together to determine which cylinder is where. The crank sensor is basically going to give it the speed of the crankshaft, and it needs that for a couple of reasons. Alright, so there's your 14.5 at sea level coming through the air filter on an old carburetor. And the manifold basically was designed so that all the cylinders, it's really important that all the cylinders get an equal amount of everything. You don't want some cylinders getting more than others. That's why your manifold was made in such a way on some of the carburetors. You might have noticed there was an upper and a lower part inside the manifold so that all of the fuel and air was traveling the same distance. You didn't want the cylinders closest to the carburetor to get more fuel and air than the other ones, or you've got a really ragged running engine. And so that's why the manifold was so carefully designed. On the carburetor, whenever the air would go through, it created low pressure here, and then through this jet below the fuel in the reservoir, it would pull that up there, and then it would mist in there. This did not provide atomization that's nearly as good as fuel injection does. And that's another reason. Furthermore, carburetors had a tendency to get out of adjustment. Things went wrong and trash was floating around in this bowl. I don't know. I mean, I worked on carburetors for 25 years. And carburetors have a tendency over time to the exhaust emissions deteriorate. Fuel injection, I've owned a bunch of fuel injection vehicles and put lots and lots and lots of miles on them. And typically fuel injection gives just the tiniest fraction of amount of trouble that carburetors do. And so just keep that in mind. Fuel injection, when it first came out, they put the fuel injectors above the throttle plate, and they kind of made it like an electronic carburetor. That started happening. General Motors had their TBI. Ford started putting these injectors in the throttle body in about 1980 or 79 or something like that. But Volkswagen, by the way, in 1968 had electronic fuel injection on theirs, and it was on the top three square back and fastback, that platform, and my dad worked on those. But you could just about buy any of the parts you needed to repair the engine controller in one of those old 68 Volkswagen fuel injected vehicles. You get just about anything you needed from Radio Shack. They had a couple of sets of points under the throttle plate that would tell it when to fire the injectors and all that. But anyway, GM and Chrysler TBI were similar but different. The TBI and the GM, that these injectors like this, typically only ran about 13 pounds of fuel pressure. And those, whenever the fuel filter is stopped up on them, it feels just like somebody put a potato in an exhaust pipe or the exhaust is clogged or something. Don't fall in that trap. You know, if the fuel filter hadn't been changed for a while and your TBI is not, you know, feels like it just doesn't have any power. You know, when a carburetor or other fuel or fuel injection engine runs with a clogged up fuel filter, when you get on the gas, it sort of loses power and then it comes back, you know. But this particular one, we got a different deal. There's still have a throttle position sensor, lots of gaskets here if you want to build that. The fuel injector was one of those. There's a lot of stories I can tell you about that. Alright, port fuel injection has got one per cylinder. Now when port fuel injection first came out, they were bank firing the injectors. Like some of the older Fords, like they came out in like, for example, Ford pickup trucks got fuel injection. I'm talking about the full-size Ford pickups got fuel injection multi-point, they call it, actually one per cylinder in 85. And 85 all the way up until 92, if I remember right, the fuel injection was bank fired. Now on your sequential electronic fuel injection on your GM, you know, that Cephei that's got the spider under there, if somebody has the cam sensor in the distributor, if they got the distributor indexed wrong, and it can't trust that signal, or if it loses that signal, it will bank fire those injectors instead of firing them sequentially, and the gas mileage goes to pot. That's one of the reasons when you put one of those distributors back in there, you got to set it using a scan tool. That's another story too. But basically, you got this damper right here that you see is basically so you won't feel the fuel injectors clicking. You know, that's a little diaphragm with a spring so that it just keeps the pressure from having these oscillations in the fuel rail, so you don't hear it under the car. The frequency of the injector's fire is determined by the crank sensor, and the timing is determined by the cam sensor. The pulse width, the amount of time the injectors are open, is determined by the other sensors, and they measure engine load, airflow, or manifold pressure. And other sensors measure temperature of the incoming air and coolant, throttle action, and so on and so forth. This is really important right here. There's a missing tooth there, you know, is what it amounts to. That gives you an idea that the cylinder, one of the cylinders is 90 degrees before top dead center when that missing tooth goes by. Alright, so you can capture the injector scope pattern on the trigger side of the injector, the one that's coming from that. Now, on these Fords, the red wire comes in to power the injectors up, and then there's a ground that's driven by that. On 87 to 90 model Jeep Cherokees, they were hooked up the other way. Of course, they had titanium oxygen sensors that switched from 0 to 5 volts, with 5 volts being lean, which was weird to begin with. And also they had the positive pulse that operated the injectors came from the engine controller. On just about every other fuel injection system you're going to find, the injectors are ground side switched, which means the pulse comes from the ground pulse comes from the engine controller. You look at a wiring schematic, you always typically notice that power comes in from the top and the ground's on the bottom. This is what the waveform looks like. That tall spike you see right there is because whenever you release that injector, it makes an inductive spike. When a field collapses, that coil creates about a 50 to 80 volt spike, depending on the system. Alright, here's the art of war, right? Know your enemy. The customer's not your enemy. The vehicle is not your enemy. The customer's concern is your enemy and must be defeated. Now, to defeat the enemy, you have to gather intel and sort it out. Color that data. You know, carburetor fuel injection, it doesn't matter. The engine needs the proper amount of extra fuel on the first cold start, but not too much. Back in the day, they used to put cold start injectors on these vehicles. They had a little extra injector that only worked on cold start up in there that would wet the manifold when you were spinning it over. And then later on, they got to the point where they would double pulse the injectors or pulse them all at the same time while you were starting it. And then whenever it would fire up, they would start firing it sequentially on Cephei engines. Cephei meaning sequential electronic fuel injection. cold engine needs more fuel in the mix than a warm engine. That's done with the pulse width on the fuel injectors based on what the engine coolant temperature sensor is giving it and the intake air temperature. When the throttle is open, extra fuel is needed even on a hot engine. When I used to use the service bay diagnostic system, I could get a neat little square wave of what the injectors were doing. And that square wave, when you would crack the throttle, it would, as you were cracking the throttle, it would put extra injector pulses in there that weren't related to crankshaft speed. And those extra pulses that were put in there were so that it was kind of like your accelerator pump. Anybody's familiar with a carburetor knows you got an accelerator pump. When you first get in there, you have to set the choke, you tap the gas, it sprays a little gas in there to wet the manifold, fires it up. Then the choke opens up about 1/8 of an inch with the choke pull off, pulls it open, then it goes all the way open in about 90 seconds or so usually. But on the fuel injected engines, those extra squirts, that you get when you first spinning it over, and then also when you're cracking the throttle, that's doing the job the accelerator pump used to do. So the engine still needs the same thing, what it amounts to, even if it's fuel injected. Too much fuel, you get a black cloud, that's your hydrocarbons, lots of hydrocarbons, or a no start and wet spark plug. Now when the spark plug is wet, the spark runs on the wet instead of jumping across the gap. That's what a flooded engine's about. PCM depends heavily on sensor inputs to make fuel calculations in high fuel pressure, a saturated canister, a stuck open injector, a ruptured fuel pressure regulator diaphragm can deliver too much fuel. If the pressure diaphragm regulator diaphragm is ruptured, fuel will go through that diaphragm into the vacuum hose that's connecting it to the intake and go right into the intake. But if you can also have a regulator that won't open and have too much pressure. I've seen that too. I've been checking fuel pressure on one that was giving intermittent rich running problems, and you could just bump that fuel and pressure regulator a little bit, and the pressure would bounce up to 100 pounds. All right, fuel burns off more efficiently the better it's atomized. The smaller the droplets, the better the burn. That's why carburetors gave way to fuel injection in the first place, and that's why gasoline direct injection fuel systems are replacing regular EFI. Now, this is a little deal here. Donnie was working on this, my friend Donnie's working on his van. He said, this thing's kicking me around. I'm working on this high mileage 90 model Ford van that had eaten his lunch and his supper for several days running. When you crank it up, it'd puff out a lot of black smoke. Now, let me say that Ford did not have data stream on hardly any of their vehicles until about 1990. Some of them in 1990. Well, 88, I think, when they first had it on any of them, and that was on the Continental. But in 1990, some of them had it and some of them didn't, depending on which transmission they had, whether they were mass airflow and this. Now, Mustangs had mass airflow in 89, but they didn't get data stream until 94, which I thought was a crummy deal because I kind of got to where I liked data stream. General Motors had data stream a long time, so did Chrysler, before it held off giving us data stream for until about 1990, 91. So it runs rich when you first start it, puffs out black smoke till it warms up. He says if it had data stream, I could do a lot more with it. The diagnostic trouble codes again aren't telling me anything. Well, in that particular Ford, it was in that limbo where it might or might not have data stream. Okay, and he was spoiled. He needed a wind into the system. Vans aren't fun to work on anyway. The scan tool data stream lets us see things like fuel trim that we can't see with hard measurements. There's no way without a scan tool that you can measure fuel trim. You just can't do it. Now, back in the day, they used to call fuel trim block learn and integrator. Integrator was the short fuel trim and block learn was the long fuel trim. GM called it that. Something like Renault used to call it that, and that kind of thing. But and those were measured at 0 to 255, with 128 being in the middle. Okay, that was a binary code thing. But anyway, the scope's necessary, but the scan tool is an easy step if the PCM will talk. So I picked up the OPD1 connector. That's what it looks like under the hood on the Fords. And I noticed that it had these two terminals in it. I said, you've got data stream here. And he said, no way. The scan tool says I don't have it. And I said, lie to the tool. It had an AOD transmission, which was the older transmission. And typically most of them, unless they had an E4OD, which was the new transmission platform in those days, they wouldn't, where they didn't have to retype the, engine controller software. See, when they put a different system on it that required engine controller programming, they just add data stream. This one, for some strange reason, even though it had an automatic overdrive transmission instead of an E4OD, which would be the old A4, I mean not A4LD, but 4R70W, I think is what they call it. Anyway, I says, tell it it's an E4OD, and it'll give you data stream. So he told him it had an E4OD, and there it was. That's how I wanted to tell. I would look at that, and I could tell if it had data stream by seeing if those two wires were there. All right, so he did what I said, and he had data stream. He couldn't believe it. I've been finding it a week. What we had a throttle position sensor that was floating just above idle when you started it up. It thought he was patting the gas when he wasn't. It was giving those extra fuel injector pulses I was talking about. And because it was giving the extra fuel injector pulses, it was putting extra fuel in there, and it was making it run rich. All he had to do to fix that was put a throttle position sensor on it. And he would have caught that if he'd have back probed the TP sensor and looked at that voltage on his meter. But the TP sensor on that one is not particularly easy to get to. I mean, you can get to it, but he never thought about the TP sensor being what the problem was. And it wouldn't throw him a diagnostic trouble code. Why? Because it was an in-range failure. And it typically, if it's within the range, that it's expecting, even if it's moving around, it's not going to throw you anything unless there's a rationality check on some of the later models, or something. But this one here wouldn't do that. All right, so that was the deal on that. Had we not known that a floating TP signal could cause rich running, we might have overlooked that then. All right. Excuse me. Technician A says, as a general rule, there is no direct electrical connection between the primary and secondary windings on distributorless ignition system coil packs. Technician B says, if one spark plug wire is disconnected from a distributorless ignition coil, the companion tower on that coil will not fire. Now, in the interest of time, I'm going to go ahead and hit you with the answers as soon as I give you a question on this one. This guy right here is correct. Look how that's wired. You don't have a direct connection, right? It's basically there are cores between those, but they're not connected to each other like the old oil field or the old potted single coil. This one here says if one spark plug wire is disconnected, we were originally told that when these systems first came out that because it was a full loop, if you disconnected one wire, the other one wouldn't fire, but that's hogwash. It will fire on that other wire even if you connect one of them. If you don't believe it, you ought to give it a try. Just make sure you do it with plastic pliers or something, because these things will light you up. They got 100,000 volts. Don't horse around with that or you kill somebody sometime. Which of the following reasons for a cylinder misfire is least likely to raise hydrocarbon emissions? A, foul plug. B, shorted plug wire. C, stuck open injector. Low fuel pressure is the answer to that one. Low fuel pressure is not going to cause hydrocarbon emissions to go up, because low fuel pressure means it's going to run lean, not rich. All right, test question 3. On the 4-liter straight 6 engine, when cylinder number 1's on compression stroke, where's cylinder number 6? Obviously going to be on the exhaust stroke, because those are companion cylinders. They go up and down together. The only thing that's different is where the valves are. All right. Test question 4. Technician A says some engines will run with the sensor unplugged and some won't. Look at that. The sensor. What was I thinking when I typed that question? Technician B says the crank sensor always produces an analog rather than a digital signal. Neither one of those guys, well, this guy's right, because there are vehicles that will, unless I meant to type cam sensor, and if you unplug the cam sensor on some of them, it'll run, some of them it won't. It depends on what it is. I mentioned this in one of these other videos, but on a Nissan Altima, if you unplug the cam sensor, if it's the 4-cylinder, it may start, it may not. But you can't count on it to start. But if it does start, you'll think, whoopee, I don't need a cam sensor, but that's hogwash. All right. So this one here was, the crank sensor does not always produce an analog signal. Some of them are digital, particularly nowadays. All right. A PCM is believed to have a bad injector driver because the injector is inoperative. Technician A says a known good PCM should be connected to the problem vehicle to solidify diagnosis. Technician B says the circuit controlled by the burned out driver should be checked for low resistance or a short. Who's correct about that? You don't ever have a vehicle, if a vehicle has got a problem like this and you've got to happen to have another vehicle sitting by, you take the suspected bad PCM and put it on the other vehicle, because it's not likely that the PCM, even if it's bad, is going to hurt the other vehicle. But if you've got a problem on the vehicle that has fried the PCM and you pull the PCM off of another vehicle and put it on there, you got 2 bad PCMs now. so don't go there. The circuit controlled by the burned out driver should be checked for low resistance or a short. All right, think about that for a minute. So this guy right here, you don't take a good PCM from a similar vehicle and put it on there. That's wrong. You ought to check it for a low resistance or a short. I had a Jeep one time that would start out squirting the injector and then it would quit clicking because that Bendix, it was a Bendix controller in an 89 model, and it would shut that injector driver down. And when it shut the injector driver down, the injector would stop clicking. And amazingly enough, it was doing that automatically to protect the driver. But the injector only had about 3 or 4 ohms of resistance. It was supposed to have 16. And so that was a bad injector on that. Technician A says there's no reason to check the ignition timing on an engine with no timing adjustment. Technician B says ignition timing should be checked anyway to eliminate it as a possible cause. This guy right here is right. Occasionally, if you got some marks and you can check the timing, it's not a bad idea to check it. On some of the Escorts, I've seen people that would put the balancer back on and wouldn't tighten the balancer bolt, and it would waller out the keyway. And of course, that thing had to, that 36-1 wheel. And as that balancer moved around, the timing would change. It would get slow, and then it would get normal. And so sometimes when you give it gas, and it would let it. Now remember, those aren't pressed on; they're just slide on there with your hand. So if you don't tighten that thing enough, and that thing is moving around, it will waller out that keyway and that balancer and cause issues. Checking the timing is not a bad idea. All right, engine vacuum reads 13 inches at no load idle on a 318 Dodge pickup engine with a distributor. This is an older one, right? Starts a little hard, runs somewhat sluggish, doesn't smoke. The ignition timing is properly adjusted, and the cylinders have an average compression of 130 pounds with very little variation between cylinders. Technician A says retarded valve timing due to a stretch timing chain may be the problem. Technician B says the timing chain stretch can be checked without removing the timing cover. All right, the stretch timing chain can cause this, and the way you check your timing chain stretch without using the cover on a vehicle with a distributor is you turn it the way that it goes with your wrench, right? Keep on turning it until you stop on your 0 on your timing mark, right? Then, watching your distributor, you turn the engine the other way until the distributor starts to turn, and as soon as that distributor begins to move, you look and see how many degrees you turned the crankshaft before the distributor started to move. And that way you know how much timing chain stretch you got. All right, we're almost out of time here. Advanced ignition timing can cause any or all of the above. Hard starting, ping, detonation, piston damage. It can cause, ping, labor knocking is what that is. Hard starting is kicking back, and piston damage. Which of the following is least likely to cause poor fuel economy? Low fuel pressure, another one. Late ignition timing wheel, running boards wheel because they catch the wind, and electrical accessories mounted too near the PCM. I have seen that, so be careful about that. What's one way you can immediately tell the PCM's awake when checking a no start? You switch it on, you hear the fuel pump running, you know the engine controller is at least awake. That's what you know. You can eliminate some things by switching it on. If you hear it go wing, you know the PCM is smart enough to turn that thing on. Here's a funny little story I'm going to close out with. I was going to set a bug on a 97 Mercury Sable that I had with a 3-liter in it for my students whenever they came, before they got there. And I'm going to cross a couple of spark plug wires on this coil. It's had distributorless ignition. I crossed a couple of spark plug wires on it, and it just so happened that the ones I crossed caused it to kick back really bad. And the first time I tried to verify my bug by starting it with those, it busted the starter housing, and the starter was swinging by the wires. So it's the last thing I would have expected. Another thing, when I was trying to plant a bug on on a Chevrolet pickup I had a little 91 S10 with a V6 in it, I was going to spray water up in a distributor. I said, I'm going to make this thing act like it used to whenever people washed the truck, So I sprayed water up in there, put it back on, ran like a brand new truck. Couldn't believe it. Of course, that stuff, it's got to basically go up in there and get beaded up on the underside, but I wasn't able to plant it. When I'm trying to break a car, it was hard. Something else I did was I took all the spark plugs out of an Oldsmobile, little V6 Oldsmobile, bent every one of the spark plug gaps shut, just bent them shut dry, screwed them back in, it cranked and ran. Didn't run good, but it cranked and ran. Now, if you dip them in oil, that would have kept them from firing. Anyway, that's a couple of little extra stories I just wanted to pass along. And hope you enjoyed this video. Hope you got some good out of it. If you didn't get some good out of it, then watch somebody else's video. I'm just kidding.